So guys, now let us understand the format of a typical layer 3 routing table entry. So many of you is already aware that what constitutes a layer 3 routing table entry, but anyway we will going to cover this again for the sake of completeness. So now you can see that we have a network sample topology here, and I will going to show you the routing table of the node S, and the routing table of the node S would going to contain routing table entries such that S would know how to reach every other device in the topology. So you can see in this topology we have 5 devices. So beside S we have 4 other devices. So needless to say that the routing table of node S would going to have 4 entries, right? And the 5th entry is a entry for the routing device S itself, right? So this is the routing table entry where first column is the destination IP address. So it is this particular destination which a router would like to reach, right? So this is the loopback address of the router C, right? And remember, we are discussing the routing table entry of a node S. So in order to reach the node C, the outgoing interface is Ethernet 0x2 and the next hop IP address is 1.1.1.1. So next hop IP address means the IP address present on the other side of the interface which is directly connected to the node S, right? So in order to reach C, D is the next hop and the gateway IP address is 1.1.1.1. And the total shortest path cost to reach the node C from the node S is 7, right? And the name of the next hop node here is the node D, right? So this is a typical routing table entry example where destination IP address is a key of the routing table entry. Key means that any route in the routing table entry is uniquely identified using destination IP address. No two route can have the same destination IP address in the routing table entry. Outgoing interface and gateways are the two important parts of the routing table entries. These two information is required for the router to know how it should send the traffic if destined to this destination, right? So these two things is the minimal thing which router should know. Whereas the next two things, that is cost and next hop node, is an optional thing to have in the routing table entry. These two information is there only to tell you more information about the routing table entry. These fields are not used by the router to forward the traffic destined to the destination in the network. So a typical routing table entry format contains a key which is a destination IP address and the forwarding information which is the gateway IP address and outgoing interface, whereas this part, that is cost and next hop node, is only for information. So this is the complete routing table of the node S, and using this routing table the node S knows that in order to reach any destination in this topology, how it should forward the traffic, whether it should forward the traffic to this interface or to this interface. So again, reiterating once again, a typical layer 3 device constructs its L3 routing table such that traffic is forwarded to the destined node through a least cost path. The traffic should be forwarded in a loop-free manner, and if there is any change in the topology, then each device in the topology must recompute or update its routing table entries in order to reflect the topological change. So to understand this point, let us suppose that router S forwards the traffic to the router C via this path, right? And this is the shortest path to reach C from S, right? Now suppose there occurs a network failure such that this link goes down, right? So all the remaining routers in the topology must be intelligent enough such that they collaboratively chooses a new path if available to reach the router C. So in case if this link fails, then the new path which the traffic destined to the router C from the source router S must take is the following path, right? Via S, D, A, B and C. So it simply means that if there are failures or change in the topology of the network, all the L3 devices in the topology must react to that change so that they continue to forward the traffic to each destination in the topology by following the 4 basic properties that we have already studied, that is least cost, loop free and ECMP. So by the end of the section of this course, you will going to understand how all this mechanics is implemented in networking.